Dear students, let us try few of the questions from the workbook, chapter 2. So the question numbers what I am mentioning here, these question numbers are related with the new workbook, that is GATE 2021. The question numbers what I am mentioning here, they are related with the GATE 2021 workbook, digital workbook. So somebody is, if at all, holding the previous 2020 GATE book, the questions numbers may be differ. Few of the questions may be same, but the order may be differ sometimes. So please take care for this change. If at all you are having any previous GATE paper, previous workbook with you, you take care. The questions what we'll discuss here, they are mostly related with the Boolean algebra. What are things we learned? The basic operators, derived operators, Boolean algebra properties, and so. What are things we learned? So let us look few of the questions from this workbook which are related with the things what we learned, because in the chapter 2 we are having questions which are even from the K-maps. So till now we not discuss the K-maps, so that such questions we are not touching. What are the things we learned? So from that, those knowledge, what are the questions we can do? Such questions I will discuss. I already given some time to you to work out. Hopefully, if at all you work out already, make a cross check for the answers. And I will speak little shortcuts on few of the questions. Let us look to the question number 4. The question number 4, it is mentioned if x is equal to 1 and this equation is given, then the question we are having from the options, what is the z value? It is a question what we are looking based on the description what we are having here. Open the workbook and see well. I am not mentioning the options because it will save some time for us. And what are the things which are required, only that part only I give written on the board. So basically what we are looking from the options is giving the value for sometimes for few options z value is given, and few options we are looking y value. So if you look here, as and when x is 1, it is possible for us to speak without doing any sort of work. This is 1, so 1 or anything, 1 or with anything will be 1. So based on this, we are having this total parenthesis which is equal to 1. So no need to do any sort of work. This total parenthesis is 1. And we are having the other flower bracket. Here we are having this equation, x is 1, so x bar is 0. And within this thing, we must be in a position to write as a 1 because the x is 1. Hence, 0 or with z bar is equal to 1. Based on this, we are speaking z must be 0. Based on this, we are speaking z must be 0. Hence, from the given options we check, the answer to this question must be option C. Answer is option C. Similarly, let us come to the next question. The next question is the 5th question from the same chapter 2. We are having here, it is a given Boolean expression. The question we are having, when this is simplified, what is the equivalent for the given options we need to identify. The question is given while giving this Boolean expression, it is equivalent to. So equivalent to what we are looking here is, which is a simplified form. We are looking here in all these terms, AC is common. AC is common in all these product terms. Basically, we are looking here, all these are the min terms. When AC is common, within the parenthesis, we are reading here BD, next B complement D, next B D complement, the last product is B complement D complement, B complement D complement. It's the last product we are having. So with our knowledge of exclusive OR and exclusive NOR, it is possible to group these two terms. While grouping these two terms, we are having it is B exclusive or D. And grouping the first and last term. Grouping the first and last term, we are having this is B exclusive or D whole complement. It is basically exclusive NOR. B exclusive or D whole complement is nothing but it is exclusive NOR. So while having this, we are in a position to speak this result must be 1. If I say it is X, it is X bar. Hence series 1. 1 series 1. 1 and with anything is anything. Anything is AC. So answer to this question, when we are doing the simplification, it is AC. And from the given options we check, I think the option B is matching. The answer, if you check, option B is matching. Similarly, let us come to the next question. The next question is question number 11. So in this question number 11, we are having basically exclusive OR operation among the literal A and A bar. So if you see here, one of the way you can look like this: A bar, A bar, A bar, A bar, A. Like this, if you read from our exclusive OR knowledge, the listing what we did while giving the truth tables. So while looking to that, if at all you want clarity, you refer back to the notes or rewind the video and you can check. While discussing the exclusive OR operation with the truth table, we are having few of the results. Those results we can use here. A exclusive or A bar is 0. Whenever A and B are not same, its XOR result is 0. Sorry, it is XOR, not XNOR. So A exclusive or A bar is 1. So based on this, it is 1, it is 1, it is 1. So we are looking here the modified expression as like this. We are having here Boolean constant 1 4 times. Whenever we are having exclusive OR operation on even number of ones, whenever exclusive OR operation is on even number of ones, the result is 0 based on the statement what we are having with the exclusive OR. Now 0 exclusive OR with A, effectively it is A. Hence the Y is simplified to A. From the given options, the answer we are reading as either maybe option B or maybe option D. In the option B, we are looking directly A exclusive or 0. It is the one what we are having. And in the option D, we are having A and A. When we are having A and A, effectively its result is A. So answer is option B as well as option D. Let us come to the next question. The next question is 12th question. So in the 12th question, we are having in the 12th question we are looking here some expression we are having. This expression is exclusive OR with A. While looking to this, we supposed to be in a position to speak what are the decimal values for these minterms. From the knowledge of the truth tables, what we discussed while discussing SOPs, POS, we supposed to be in a position to read equivalent decimal values for each one of this minterm in the bracket. So this is minterm 4. This is minterm 2. How we are speaking this? If you take a question, we are having here A must be 1. We are having B and C with 0. B and C with complement. Whenever B and C are with complement, B as well as C values must be 0. So 100 is a decimal 4. But with the practice, you must avoid all this. You must be in a position to read this directly. So you can do that with your self practice. Like this, if you look, it is a minterm 7, it is a minterm 1. So basically what we are looking, this total bracket which is consisting of the minterms 1, 2, 4 and 7. When we are having it is the group of minterms 1, 2, 4, 7, Again, if you refer back to the exclusive or three variable truth table, this equation I given, and there while giving this equation I was mentioning on three variables it is a odd function. If you are remembering well, without referring to that, you can see if at all they are not remembering, refer to the rewind the video or go back to the notes and you can check. So effectively I can speak, this is nothing but all these together. This we are having possibility to read as A exclusive or A exclusive or B exclusive or C. So when we are having minterms as 1, 2, 4, 7, effectively it is exclusive or between A, B and C. And this is exclusive or with A. Associativity is valid on exclusive or operation. Because of this A and this A we can group. We are having possibility to read A exclusive or A result as 0. So 0 exclusive or B exclusive or C effectively we are reading. Hence the simplification we are reading as B exclusive or C. Once the simplification is a B exclusive or C, from the given options the matching answer is option A. The answer from the given options is option A. Let us come to the next question. The next question number I mentioned as 15. If you look at the next question, we are having some lengthy expression. And we are looking here, when it is simplified, what is its equivalent value from the given options is a question. When it is simplified, what is the answer from the given? If you see, we are looking without bothering to the first bracket, we are having possibility to speak the answer. This total thing we can read simply as 1. So this total thing we are having possibility to read as simply 1. Because this is resulting C exclusive or D complement. This is one term. Other term of course as it is available in the given expression. So within this square bracket what we are having is, if we speak C exclusive or D as X, this is X complement. So when we are having X and X complement with OR operation, they are related with OR operation, we know from the fourth property the result must be 1. And 1 OR with anything is 1. Hence from the given options the answer is option D. From the given options, the answer is option D. Earlier question I mentioned, I think I mentioned as question number 15, but in the new workbook it is not question 15, it is a question 13. So take care for this. The new workbook question number is 13, of course answer is same. Let us come to the next question. The next question is question number 7. The question number 7 is exclusive or between X, Y and this X and with Y. Exclusive or between X, Y, exclusive or with X, Y. So when we are having this result, if you try well, Y exclusive or with X, Y, if you try well, here we are having in both these terms Y is common, and if you try well, the result of this must result X complement Y. If you try well, the result is X complement Y. If you are remembering good, otherwise you have to go with the normal expansion. If you are remembering, it is shortcut. If you are not able to remember, it won't take much time also if you evaluate. So if you evaluate this, we will be looking this as Y complement and with XY, or with Y XY complement, because you can read this as A, this thing as a B, so that A complement B or with A B complement. This first product must be 0 because y complement we are having. And second one, expanding using De Morgan's property, the result will be x complement y. What I mentioned, it's the result. Because y complement we are having, that is 0. Effectively, it is reducing to only x complement y. Hence, we are substituting here this as x complement y. It is exclusive or with x. While expanding by using exclusive or operation relation, this will be x complement and with x complement y or with x complement y complement. So while expanding this, it is the one what we are having. So this is x complement y effectively. Here x and with x or y bar, this is coming as x and with x or y bar. So work out well, it is simply x because this is x or with xy bar. So while taking x as a common, 1 or with y bar, so it is 1. Effectively it is only x. Such a practice is expected from the properties. When I am having xr with xy bar, one of the property what we mentioned in our list, if you check, probably it is property number 8. You must be in a position to write directly as x. If you are having good practice, you can cut down the time. Otherwise, of course, you need to spend a little time. It won't take much time, but you need to spend a little time. Now, by using distributivity, if you work, this is x or y. Hence, from the given options we check, the answer to this question is option B. Let us come to the next question. That is question number 10. It's a very good question. Question number 10 is very good question. You read the statements what are available in the question description. Anyway, I written the statements on the board, but workbook is available with you. You read yourself the statements what we are having. So one statement we are having, if the output waveform from an OR gate is the same as the waveform at one of its inputs, the other input is being held permanently low. So we are having a statement which is on basically description is giving a means on a 2 input OR gate. The description what we are having, the statement 1 is on 2 input OR gate. And statement 2, S2. Statement 2 is S2. The statement 2 is if the output waveform from an OR gate is always high. If the output waveform from an OR gate is always high, one of its input is being held permanently high. These are the 2 statements we are having. And based on the question, we need to identify whether the statement 1 and statement 2 both are true, or any one of the statement is true, or both are false. These things basically we need to identify. So it is mentioned the statement are statements which is or always true. So from this statement 1 and statement 2, which is true or which are true is a question. Both are true or both are true or one of this is true, or equivalently which is correct, which is not correct, or which is true, which is false. Anyway, so if you look here, both these statements we are having on a 2 input OR gate. The statement 1 is talking if the output waveform of an OR gate. Suppose this is a 2 input OR. 2 input OR, one of the input is A, other input is B. If the output waveform of an OR gate is the same as the waveform one of its input, the other input is being held permanently low. Suppose I am having the input A waveform as something like this. And we want output from this OR gate. We want to read the output from this OR gate same as the input A. Same as the input A. Then based on the statement, he is mentioning that is possible if at all the other input is held permanently low. So we are looking a statement as the output Y is possible to read same as the one of the input, same as the input A, based on this being held permanently low. If and only if at all the other input is permanently held to logic 0. Low is basically referring to the logic 0. And high is basically referring to logic high. Logic 1. High is basically referring to logic 1. Low is basically referring to logic 0. So, if the output waveform of an OR gate is same as the one of its input, the other input is being held permanently low. If we want to read the output same as one of its input, is mentioning the other input must be connected to the logic 0. In other way, it is possible to read output same as the input A if and only the other input is permanently connected to 0. That is statement is talking. We need to check whether the statement is true or not. Of course, if you see here, if you are having a B waveform, the B waveform something we are having like this, and this waveform what we are having here is, it is neither permanently 0 nor permanently 1. I am not keeping the input waveform basically permanently logic 0. So without keeping the B input, the second input permanently 0, I am reading output same as one of its input, same as the input A. So that if we want to read output same as the input A, no need to be the other input is permanently to logic 0. No need to be other input is permanently logic 0. If we are keeping other input is permanently logic 0, of course, the output is same as the input. But it's talking, it is possible if and only if at all we are having other input is permanently logic 0, is being held permanently 0. So without keeping the other input be permanently 0, we are having the output same as the input A, same as one of its input. Based on this statement, 1 is false. Based on this, the statement 1 is false. Similarly, we have to check the statement 2. The statement 2 also on 2 input OR gate. In the statement 2, what we are looking is, if the output waveform of an OR gate is always high, one of its input is being permanently high. So suppose I am having Y as something like this permanently high. Now he is mentioning one of its input must be permanently high. In other way, one of its input, if at all it is permanently high, then only we are having output is high. That is a statement you want to make. But we can see here, suppose I am having one of its input A is like this. I am having the B input say like this. So what I am looking, either A or B input, any one of the input is not permanently 1. Without keeping any one of the input permanently high, if these are the inputs to this OR gate, correspondingly the output is always 1. Correspondingly the output we are having always 1. So without keeping one of its input permanently high, where reading output is 1. But the statement what is mentioning is if the output waveform of an OR gate is always high, one of its input being permanently high. It is possible, he meant to say it is possible to read the output is high if and only one of its input is permanently high. As I said already, high means logic 1. So based on this, we are looking, no need to keep any one of the input permanently high. Without keeping any one of the input permanently high, also we are having output is high. So this statement also false. Hence, from the given options, the answer for this question is option D. The answer to this question is option D. So the option D is none of these. So we are not having any one of the statement is true. So none of these statements are true. It is the answer. Without looking to this waveform statement 2, we can make a answer. We can give a conclusion from the truth table of R. This is the truth table for OR operation. We are looking here. Without keeping any one of the input permanently high, we are having output is 1. So no need to keep one of the input is always high to read the output is high. Hence the statement 2 S2 is false. So like this also we can see. But better read the statement 1 with such sort of waveform. It is giving more clarity. The statement 1 is if the output waveform of an OR gate is the same as one of its input, the other input is being held permanently low. So better try to look to the reasoning for the statement 1 with such waveform. But statement S2 is concerned, you can read directly from this truth table also. Come to the question number 15. So in the question number 15, we are having some block box. We are having one input is V, other input is A, and A input is named as a control input. This is output. We are looking A input, some waveform as like this. Now the question is block box. What is the box we are having here? Block box inverts the phase of its input V when control input is A. That is control input A is 1. And let it pass through uninverted when control input A is 0. The circuit is, it is a question. So what is mentioning is the waveform what we are having here. This waveform is resulting from the output as inverted waveform. It is resulting from the output as inverted waveform whenever control input is 1. So whenever control input is 1 is mentioning it is inverted waveform. And when the control input is 0 is mentioning waveform is as it is. Waveform is as it is. If that is the operation we are having from this block box, what is the logic circuit in the block box is a question. If this is a waveform. So if you are remembering well exclusive OR truth table or the results what we mentioned with exclusive OR truth table, it is possible if and only if in the block box we are having exclusive OR gate. The exclusive OR gate is giving inversion operation whenever one of the input is 1, and exclusive OR gate is giving the buffer operation whenever one of its input is 0. On the waveform we are having inversion means it is nothing but out of phase. Based on the question you can see Block box inverts the phase of input. Inverting phase is nothing but out of phase. So wherever one we are having with respect to this waveform, if you speak, it must be 0. Wherever we are having 0, it must be 1. It is out of phase. So out of phase we are reading whenever A is 1, blue color, and we are reading output same as the input whenever control input is 0. Hence this gate is exclusive OR gate. From the given options, the answer is option B. So let us come to the next question. The next question is try yourself question from the chapter 2. The answer anyway it is printed there. I think the option is option D, that is 4. The question what we are having is, in the given logic circuit, the wording may not be same, but you read the question yourself. If you want, I can read the statement. Consider the following circuit consisting of exclusive OR gates and non-inverting buffers. So these are the exclusive OR gates, and these two gates what we are looking, they are non-inverting buffers. The non-inverting buffers have delay delta 1 2 nanoseconds and delta 2 4 nanoseconds as shown in the figure. Both XR gates and all wires have zero delay. Assume that all the gates, outputs and wires are stable at logic level 0 at time 0. If the following waveform is applied at input A, how many transitions occur at B during the time interval 0 to 10 nanoseconds is the question. So basically what we are looking is, in this circuit we are having two exclusive OR gates and two non-inverting buffers. One of the non-inverting buffer, that is a delta 1, is having a propagation delay as 2 nanoseconds. Other non-inverting buffer delta 2 is having a propagation delay as 4 nanoseconds. And we are having, based on the question description, no other devices, that is XR gates particularly, or connecting wires are not having any delay. Now the question is, as and when this input A is applied, so the input A is changing abruptly from logic 0 to logic 1 at t equal to 1 nanosecond. When such input is applied to this logic circuit, the output B, the overall circuit output is B. The output B is having how many transitions? It is a question. So when such input waveform is applied, then output is having how many transitions at the output is a question. So be clear, don't confuse while looking to these symbols as inverters, as NOT gates. Don't read wrongly as NOT gates. They are non-inverting buffers. This buffer we already discussed while doing one of the problem earlier. Whether we are speaking it is a non-inverting buffer or we are speaking as a buffer, it is one and same. So buffer is basically producing the output same as the input. If the input is A, output will be same A. The buffer operation is just sending the input signal as it is to the output. Here the XR gates are not having any delay as per the question description. Connecting wires also not having any delay. The delay associated in this circuit is only because of this delta 1 and delta 2. To speak how many transitions are there for the output waveform during the time interval 0 to 10 nanoseconds, the output B is having how many transitions is the question. The transition is nothing but changing its logic value. So changing maybe 0 to 1 or changing 1 to 0, each one is one transition. So how many such changes we are having, maybe 0 to 1s or maybe 1 to 0, how many changes we are having to the output B for this applied input A is a question. The A input is changing logic 0 to logic 1 at t equal to 1 nanosecond. We are having answer for this question. We are having possibilities to speak the answer on this question if you know the output waveform B for this applied input. We are having possibility to draw the output waveform B if and only if you know both the inputs to this gate. Let me name this as a gate G2. Let us name this as a gate G1. So while knowing both the inputs of the gate G2, possible to draw the output waveform for the gate G2. The gate G2 is getting input from the output of this gate G1. Hence, unless we don't know this gate G1, not possible to draw the output waveform of B. After knowing the gate G1, possible to speak both the inputs of this gate G2, so we can speak what is the output waveform, or we can draw what is the output waveform. The gate G1 is having one input, directly applied input, other input is after this buffer delta 1. So gate G1 waveform possible for us to draw after knowing the delta 1 output waveform. Hence, our solution supposed to start while giving the waveform for delta 1 output. After knowing the waveform of the delta 1 output, we are giving the waveform of the gate G1 output. After knowing the gate G1 output, we are giving the waveform for the delta 2 output. After knowing delta 2 output, finally we will try to draw the waveform for B. After drawing the waveform for B, we are speaking the answer to this question. The output B is having how many transitions during the time interval 0 to 10 nanoseconds for this applied input signal. So let us start first, as I said, for delta 1 output waveform. Output of the delta 1. So let's go with the same scaling. Zero, 1, 2, 3, 4, 5, 6, 7, and so on 11. Delta 1 is a buffer gate, non-inverting buffer, as I said already, is a buffer gate. So what is the input we are having? The same is available at the output, but delta 1 is having a delay of 2 nanoseconds. A similar question we discussed earlier. So with the knowledge of that, let us try quickly. So whenever we are applying the input, the delta 1 is instantaneously not giving the output. To respond for the given input, it is taking an amount of time 2 nanoseconds. It's a lazy gate. It is responding only after 2 nanoseconds. So based on this, see, if you are sorry, if you are sleeping, somebody is hitting you. You may not be wake up immediately. You may take some time to wake up. The same thing is happening here. This gate is sleeping. When this is hit with this gate is hit with this waveform, it is responding only after 2 nanoseconds, something like this. So looking to that, if you see here, before 1 nanosecond, the delta 1 input is 0, so the delta 1 output is 0. At 1 nanosecond, the delta 1 input is changing 0 to 1, but it is responding only after 2 nanoseconds. It is responding only after 2 nanoseconds means it has to continue the same earlier value until 2 nanoseconds. So somebody is hitting you when you are sleeping. You will be sleeping some more time. Here the sleeping is lasting 0. So it will continue same value until 2 nanoseconds. It is a delay associated with the delta 1. After 2 nanoseconds, it is giving a response as 1. Later, there is no change to the input of the delta 1. Hence, there is no change to the output of the delta 1. Hence, it is a waveform from the delta 1 output. Now, we are looking here, these two things combinedly inputs of gate G1. These two things are combinedly the inputs of the gate G1. Knowing these inputs, we are looking now quickly. So knowing this, we are quickly giving the waveform of the gate G1. So G1 is exclusive OR gate, XOR gate truth table. We know whenever both the inputs are same, XOR result must be 0. Whenever both the inputs are not same, XOR result must be 1. So knowing that, we are looking here. During the time interval 0 to 1, both the inputs are 0. When both the inputs are 0, it is 0. During the time interval 1 to 3 nanosecond, one input is 1, other input is 0. Hence, during this time interval, we are having it is the output. Later from 3 to 10 nanoseconds, our interest is up to 10 nanoseconds. Later from 3 to 10 nanoseconds, both the inputs are with a logic 1. When both the inputs are with a logic 1, we are having no change to the output of the exclusive OR gate. Hence, the exclusive OR gate output we are having this pulse waveform, you can speak with a pulse duration of 2 nanoseconds. In the time interval 1 to 3 nanoseconds, there is a pulse, and of course, pulse width will be based on the scaling, it is a 2 nanoseconds. This is the output of gate G1. It is the output of the gate G1. In other way, it is the input of delta 2. In other way, it is the input to the delta 2. Knowing the input of delta 2, we are having possibility to draw the waveform of the delta 2 output. Delta 2 also non-inverting buffer. Whatever the input we are having, it is resulting as output, but it is also a lazy gate. For the applied input, it is not responding instantaneously. For the applied input, it is responding only after 4 nanoseconds. So, knowing all this knowledge, we are looking quickly the delta 2 output. So, same waveform we supposed to read, but it's supposed to be delayed by 4 nanoseconds. This pulse is applied to the delta 2 at 1 nanosecond. But because of the delay associated with the delta 2, it is responding after 4 nanoseconds. So, 1 plus 4, 5. So, after 5 nanoseconds, this pulse is to be available. So, pulse is the pulse duration of 2 nanoseconds. So, this is 2 nanoseconds. Hence, during the time interval 5 to 7 nanoseconds, we are having the output waveform from this delta 2. The delta 2 output is a pulse waveform that is in the time interval 5 to 7 nanoseconds. It is one of the simplest way to talk about this. The response of the delta 2 output of delta 2. So, if I repeat quickly, this is the waveform what we are having at the delta 2 input. The same waveform must be available from the delta 2, but to respond this, delta 2 is taking 4 nanosecond. It is applied at 1 nanosecond. So, response we are having after 4 nanoseconds. So, 1 plus 4 after 5 nanosecond we will be having response. It is to be repeat. So, it is to be repeat. In fact, the pulse duration is 2 nanoseconds. It is one way to speak. Alternatively, you can speak here little more detail if you want. I can speak little alternatively, something like this. The delta 2 input is changing 0 to 1. Delta 2 input is changing 0 to 1 at 1 nanosecond. So, delta 2 output must change again because the input delta 2 output must change 0 to 1. But to change, it is taking 4 nanoseconds. So, 1 plus 4 after 4 nanoseconds from the applied input, that is 1 plus 4, 5. At 5 nanoseconds, it is changing 0 to 1. It is changing 0 to 1. Delta 2 input is changing from 1 to 0 at 3 nanosecond. So, delta 2 output must change from 1 to 0 with a delay of 4 nanoseconds. So, 3 plus 4 after 7 nanosecond, it must change from 1 to 0. So, like this also you can think. At all other places, of course, 0. So, output of the delta 2 is 0. As per your convenient, you can understand, you can catch the point. Either maybe applied input is delayed by 4 nanoseconds like this in a simplest way, or little detail if you want, we can speak what I said. The delta 2 input is changing 0 to 1 at 1 nanosecond. So, delta 2 output will change after 4 nanoseconds. So, 1 plus 4 after 5 nanoseconds changing 0 to 1. Delta 2 input is changing 1 to 0 at 3 nanosecond. So, delta 2 output will change after 4 nanoseconds. So, 3 plus 4, 7 nanoseconds changing 1 to 0. So either way, answer is this. We are looking now, these two are combinedly inputs of gate G2. Knowing these inputs, we are looking now the output waveform of the gate G2. Output of gate G2 these are the inputs. Whenever both the inputs are not same, XOR result is 1. We are having here during the time interval 1 to 3, both the inputs are not same, so XOR result is 1. During the time interval 5 to 7, both the inputs are not same, so output is 1. During the time interval 1 to 3, one input is 1, other input is 0, so it is 1. During the time interval 5 to 7 nanosecond, one input is 0, other input is 1, so 1. And other places, always we are having both the inputs are 0, so output is 0. Hence, it is a waveform what we are having the overall circuit output. It is a delta 2, it is a gate G2 output. It is gate G2 output. The gate G2 output is mentioned in the problem description as the overall circuit output B. So for this applied input, we are having the changes at the output B. How many times? Based on the question we are looking, it is one change at 1 nanosecond, second change at 3 nanosecond, third change at 5 nanosecond, third change at 5 nanosecond, fourth change at 7th nanosecond. So that output is having a transition because applied input 4 times. Hence, answer to this question is 4. From the given options, we are speaking answer is option D. It is one of the good question. It was a question in the GATE CS paper in 2003. It was a question with a weightage of 2 marks. I given a question as a homework question to you earlier. The question was, maximum how many number of functions are possible? Maximum how many number of functions are possible so that f of xyz is equal to f of x y complement z? It was a question. Maximum how many functions are possible so that f of xyz is equal to f of x comma y complement comma z. It was a question I given to you some time back. Let's look to the solution to this. Suppose the product form for 0, min term 0, is x complement, y complement, z complement. Let us take the complement operation only on the literal y complement because it is a condition we want to follow to check the answer to this, to identify the answer to this. So this is coming x complement, y, z complement. The equivalent decimal number for this is 2. These two terms must be named as mutual exclusive terms on variable y. They are mutual exclusive terms on variable y. The similar work we did while discussing maximum how many number of self-dual functions are possible with 3 variables. When we were looking to this sort of work there, they were the mutual exclusive terms on all the 3 variables x, y and z. But whereas here we are looking, while taking the complement on the literal y bar, they are the mutual exclusive terms only with respect to single variable, that is on y. The similar work let us extend for the remaining products on these 3 variables. The product form for term 1 is x complement y complement z. While taking complement on the literal y complement, it is x, y, z. The equivalent decimal number is 3. So it is also a mutual exclusive pair on variable y. Similarly, the product form for 4 x, y complement, z complement. While taking the complement on the literal y complement, it will be x, y, z bar. It is a decimal number 6. It is also a mutual exclusive pair on variable y. And one other last pair possible, that is 5 and 7. 5 product form is x, y complement, z. While taking the complement on the literal y bar, it is x, y, z. The equivalent decimal number is 7. So it is another mutual exclusive pair on variable y. So with respect to variable y, we are having, there are 4 mutual exclusive pairs. One pair is 0, 2. Next 1, 3. Next 4, 6. Next 5, 7. These are the 4 pairs. They are the mutual exclusive pairs on the variable y. Now let us try few functions to satisfy the condition what we need. Suppose I am having a function f1 on the variables x, y, z with the minterms of 0, 2, 4, 6. The minterms 0, 2, 4, 6. Other function f2 is on x, y bar, z. Here also consider the minterms are same 0, 2, 4, 6. We want to read expanded canonical form. For reading expanded canonical form, let us consider y bar as say a, so that y becomes a complement. Y bar is a, so that y becomes a complement. Now using this notation, while replacing this as a, let us read the product for each one of this minterm. The product we are reading as x complement, a complement, z complement, x complement, a, z complement, x, a complement, z complement, x, a, z complement. In the first product and in the third product, we are having a complement. So a complement we need to replace with y. A complement we need to replace with the y. The substitution what we did based on this. So this will be now x complement y, z complement. This will be x, y, z complement. And the second and the last term, we are having A. A must be replaced with the Y complement. A must be replaced with the Y complement. So X complement, Y complement, Z complement, X, Y complement, Z complement. If you read the products equivalent decimal values here, it is a decimal 2, it is a decimal 0, it is a decimal 6, it is decimal 4. So it is basically with the minterms of 0, 2, 4, 6. And if you see here, the same function f1, which is on the variables x, y, z. Based on this, we are recognizing this f1 and f2 are same. They are satisfying the condition, whereas f1 is on the variables x, y, z, whereas f2 is on the variables x, y complement z. Instead of y, it is y complement z. So we are able to look here, f1 is equal to f. So it's a required condition based on the question. Similarly, let us try for one more example. It's a one set what we considered. Let us go for next set. In the next set, let us read the functions with only two minterms. Consider we are having the minterms as 1, 3 for f1. f2 is on x, y complement z. Minterm here also 1, 3. Now, while expanding the product form, as usual, y complement is to be replaced with a, y will be replaced with the a complement. So this I am talking a. So in terms of a, let me write first. X complement, a complement, z, x complement, a, z. Whereas a complement is to be replaced as a y. X complement, y, z. A complement we are replacing as a y. A we are replacing with y bar. Hence we are looking here. It is a minterm 1, it is a minterm 3. So we are looking here, it is a function with the minterms of 1 and 3. This we are looking, it is same as your f1. f1 is having the minterms as 1 and 3. Hence, we are speaking now, f1 is equal to f2. So this condition what we need, it is satisfied. The condition what we are looking, it is satisfied. If you check like this, taking any one pair as a total minterms in the f1, here in the second case 1, 3, it is a total pair. It is a total pair. Like this, while taking any pair, complete pair as the minterms, we are having to build the functions on two minterms. So such functions, how many functions are possible? We are having possibility of 4 functions. So 4 pairs we are having, out of 4 pairs, any one pair is a minterm. 4 pairs we are having, any one pair is a minterm. Hence, total, how many possible if you look? 4C1. Total 4 pairs, any one pair is a minterm. So, how many functions are possible to satisfy this condition taking 2 combinations of the minterms? Definitely it is a 4C1. In the first case, if you look, the minterms are 0, 2, 4, 6. Once the minterms are 0, 2, 4, 6, what we are looking? We are having here the usage of the first pair and this third pair. First pair and third pair. Based on this example, it is possible to elaborate. Like this, if at all we are looking, to satisfy this condition, from these pairs to develop the functions with 4 min-terms to satisfy this condition from these pairs to read the functions with 4 min-terms, we need to take any two pairs, any two complete pairs as a min-terms. While taking any two pairs, complete pairs as min-terms, whenever we are developing the functions, those functions based on this example definitely will satisfy this condition. Definitely they will satisfy this condition. You can try on your own few other examples taking any two pairs instead of this. So from our mathematics knowledge now we can speak out of 4 pairs, any two pairs we are taking as a min-terms. Out of 4 pairs we are taking any two pairs as a min-terms. So total, how many functions are possible with 4 min-terms to satisfy this condition? How many functions are possible with 4 min-terms to satisfy this condition? The answer definitely must be 4C2. Hence it is 4C2. Right here, 4C2. Now this logic, if we extend, if we want the functions with 6 min-terms instead of 4 min-terms, we want the functions with 6 min-terms, and the functions must satisfy this condition. The functions we want with 6 min-terms, the functions must satisfy this. Functions must satisfy this condition. Then definitely 6 min-terms if we want, then it required for us to take any 3 pairs. While choosing any 3 pairs, the functions what we will be developing will be having 6 min-terms, will be having total 6 min-terms. So how many such possibilities we are having if you take the question? Definitely the answer is out of 4 combinations, 4 pairs, any 3 pairs we are taking as a min-terms, so 4C3. When we are taking any 3 pairs as a min-terms, the total number of min-terms will be 6. And if you choose properly any 3 pairs with the 6 min-terms, we will be having functions which will satisfy this condition. Similarly, while satisfying this function, if you want a function with 8 min-terms, while satisfying this condition, we want to have the functions with 8 min-terms, because on 3 variables total 8 combinations are possible. Hence I can speak that also. So to satisfy this condition, while satisfying this condition, if at all we are developing the functions which will be having 8 min-terms, then definitely we need to take all these 4 pairs as a min-terms. When we take all these 4 pairs as a min-terms, 4 into 2, 8 min-terms. So how many possibilities we are having? The possibilities will be 4C4. So when we are taking all these 4 pairs as a min-term, so all the combinations are the min-terms. When all the combinations are the min-terms, for any value of x, y, z, or any value of x, y complement z, for any value of x, y, z or x, y bar z, we are having always the function output is 1. Okay, anyway, how many if at all we are looking? It is 4C4. Only one possibility. 4C4 is 4C0. Only one possibility will be having. Similarly, we can think, in this case, all the combinations of the min-terms, you can have function, all the combinations may be max terms. When we are talking all the combinations of the max terms, then what we are looking with this notation, from these 4 pairs, we are not choosing any pair as a min-term. When we are not choosing any pair as a min-term, then default means all the combinations are the max terms. So how many such functions are possible to satisfy this condition? All the combinations of the max terms, the answer will be 4C0. Answer is 4C0. So from this, we are looking to the answer. How many total number of functions are possible to satisfy this condition? While looking to this, you can speak now the answer must be 16, because we are looking here 4C0 is 1, 4C1 is 4, 4C2 is 6, 4C3 is nothing but 4, 4C4 is nothing but 4C0, 1. So while adding this, we are looking here 6 plus 4, 10, plus 4, 14, 15, 16. So total, we are looking the quantity as 16. So total number of functions are possible. While satisfying this condition, the answer is 16. It was the answer on this question. On these three variables, we are having 16. Now, based on this, suppose we want to look more generically on n variables. When we are developing such functions, maximum how many functions are possible? The answer is supposed to be to the power of n minus 1. Verify when n is 3, so it is coming to the power of 3 minus 1. So 3 minus 1 is 2 to the power of 2, 4 to the power of 4 is 16. I am talking whenever n is 3, this will be to the power of 3 minus 1, hence to the power of 2. So to the power of 4 I said, so it is 16. So this rule you can extend even for 4 variables, 2 variables, and so on. You can extend this sort of knowledge what we discuss in general for a function may be with any number of variables. And this sort of question we can think may not be on single variable. You can make the question may be similar to this, something like this also. We are having a question, how many functions are possible, maximum functions are possible, so that f of x complement y z complement is equal to f of xyz. Either way, how many functions are possible so that f of xyz is equal to f of x complement y z complement. Either way, it is one and same. Even the answer on this question, if you try like this, will be only 16. So when you are trying to look to the answer to this, the work what is expected is we must develop the mutual exclusive terms on variables x and z, on 2 variables. For the earlier question, the mutual exclusive terms we developed on only 1 variable because y is complement. Here we are having complement on x and z. Because of this, we need to develop the mutual exclusive terms on 2 variables. So anyway, because of 3 variables, 8 combinations, mutual exclusive pairs we are developing, then definitely 4 pairs. The story after developing the 4 pairs same. We can take any 1 pair or 2 pair, 3 pairs, or all the pairs, or all the combinations of the max terms, either way. So finally the answer is resulting to be 16. As a matter of interest, just for 1 pair I will discuss. Suppose 2. The 2 product will be x complement y z complement. We want now the complement operation on the literal x bar as well as z bar. Then it is coming x, y, z. The corresponding decimal number is 7. Then we are looking this 2 and 7 are the mutual exclusive terms. They are mutual exclusive terms on the variables x and z, Whereas there we are having the mutual exclusive terms on only single variable, that was y. Now here we are having the mutual exclusive term on variables x and z. Like this we need to list. So definitely we will be having 4 pairs. As said, once we are having a 4 pair, this sort of listing will be having, and from this, when we are trying maximum how many number of functions are possible, definitely this sort of equation you can read. With this equation we are looking to the answer to this is 16. So let us take this question. Using n number of Boolean variables, maximum how many number of Boolean functions are possible? It is one of the standard question. It was the question in the GATE paper couple of times, many times. No need to talk which year, many times. Even recent times, 2014 it seems it was a question. 2011 it was a question. Many times, if you look previous papers, maybe in EC or maybe in E or CS paper, many times very regular question. And it may be sometimes a general case on n variables, or it may be sometimes a specific numerical value. It means it may be the case sometimes by using two Boolean variables, maximum how many number of functions are possible, or by using three Boolean variables, maximum how many number of functions are possible, or maybe by using four Boolean variables, maximum how many number of functions are possible. So like this, sometimes we are having the question this with specific so sometimes it will be the case for specific number, maximum how many number of Boolean functions are possible. So if we are having a question like this, just think, by using two Boolean variables, maximum how many number of functions are possible. Say by using three Boolean variables, maximum how many number of functions are possible. So don't say by using two Boolean variable 4 or 8 something, don't speak, they are not the right answers. Or by using three variables, don't speak 8, they are not the right answers. If you try well with our mathematics knowledge here, no need of any electronics knowledge required, no need of digital electronics knowledge required. Here basically we need the knowledge of the mathematics. By using two Boolean variables, if you try well, maximum 16 different functions are possible to develop. Similarly, by using three Boolean variables, maximum 256 Boolean functions are possible to develop. By using four Boolean variables, maximum 64 into 1024 different Boolean functions are possible. While looking to these numerical values, definitely possible to recognize by using n Boolean variables, maximum how many number of functions are possible. The formula possible to look as to the power of n. The formula possible to look as to the power of n. In this case, n is 2, so that to the power of 2, so to the power of 4, effectively 16. In this case, n is 3, so to the power of 3, effectively to the power of 8, because to the power of 8, it is 256, and so on in general. In this case, to the power of 16, to the power of 4. So to the power of 4, 16. So to the power of 16. So hence it is coming 64 into 1024. So it is a formula which is possible. Okay, if this is a question in the written exam, with this formula you can speak the answer. But suppose the same question you are facing somewhere in the interview, somewhere in the Defense Lab interview or ISRO interview or any PSU interview, you face the same thing as a question. If you speak of course the question will start by using n Boolean variables or by using specific number, by using two Boolean variables, maximum how many number of functions are possible. Then of course, knowing this formula you are giving on two variables, the answer is 16. But definitely you know well, the question won't stop there in the interview. The question will continue. The continue is, can you justify your answer? That is the immediate question you'll be having. Basically, while putting this as a question, his interest is not on you, the answer what you are talking. His interest is basically to know how you will be explaining the answer is 16. His concern is how you are expressing, how you are giving your explanation to the answer, how you are following your logic to explain the answer. That is concerned most of the times. So just think how you can think the answer on this. And of course, what is the answer you will be giving? It's supposed to give impress to listeners. Zigzag randomly answering is not good in the interviews. You have to give answer in such a way, a specific logical way. You have to give the answer, not very vaguely. So let me speak. One of the possible way we can speak the answer as like this. On these 2 billion variables, there are 4 possible combinations. These are the 4 possible combinations. We are having possibility to develop the function taking any one combination as a minterm. So consider I am having a function f1 on the variables ab, taking only the combination say 0 as the minterm. Like this, if you look, we are having possibility to develop 4 different functions taking only one combination as the minterm. Taking only one combination as a minterm. Similarly, possible to think taking two combinations as the minterm, say 0, 2, say 1, 3, like this. So out of 4 combinations, taking two combinations of minterms also we can develop the functions. And if you are having a question, taking two combinations as the minterms, how many functions are possible? With our mathematics knowledge, the logical way possible to speak as 4C2. Out of 4 combinations, we are taking the out of 4 combinations, we are taking any 2 combinations as the minterms. So when we are taking any 2 combinations as the minterms, the functions what we are developing, they will be resulting with the 2 minterms. The functions will be with 2 minterms. Hence, we can speak it is 4C2. So while making a list, we should not speak the answer as so and so. Of course, while making the list, you will be having answer, no doubt 6, but listing is not advisable. Better to speak as 4C2. So based on this, the previous one, taking one combination as a minterm, definitely our answer for this will be 4C1. The same thought process, if we are extending, taking 3 combinations as the minterms, 0, 2, 3, 0, 1, 2. So taking 3 combinations as the minterms, the same thought process, if we are extending, then definitely with 3 combinations as the minterms, how many functions are possible? Our answer is 4C3. Taking all the combinations as the minterms, all the combinations as the minterms means we want to use all the 4 combinations as the minterms. When all the 4 combinations as the minterms, then definitely the same approach if we speak, it must be 4C4. When all the combinations as the minterms, then what it means, for any value of AB, the function output must be 1. For any value of AB, the function output must be 1. So, if you are evaluating this, it is 4, it is 6, 4C3 is nothing but 4C1, so 4, 4C4 is 4C0, it is 1. So, while adding all these integers, we are having answer as a 15. But I mentioned answer is 16 there, of course, using this formula. You mean to say the answer what we mentioned, is it approximate answer? Or the formula what we are talking, is it a closed answer? Is it not exact answer? Definitely on this question, your answer must be no. It is not closed answer. It is exact answer. The answer is 16. The formula is exact formula, not closed answer. If the answer is exactly 16, then the question is, where is the missing function? Where is the missing function? Based on the discussion what we are having here, I said a function, all the combinations as the minterms, 4 combinations as the minterms. You can think in reverse now. There may be a function, then in that function, all the combinations are possible to be maxterms. There may be a function there where having possibility all the combinations as the maxterms. When all the combinations are the maxterms, then it must be 4C0. It must be 4C0. So 4C0 will be 1. 4C0 will be 1. In that case, the answer is not 15. The answer is 16. So this formula what we are having here, possible to extend more generically as when we are extending this formula, it must be to the power of n C0 plus to the power of n C1 plus to the power of n C2 and so on. The last term must be to the power of n C to the power of n. It is a binomial expansion from this. With our mathematics knowledge of 11th class, 12th class, the formula we are talking as to the power of n. Hence, there is a thing what we mentioned here as the answer is the one what we mentioned as the answer. The question what we are looking, the question we are having here, using n Boolean variables, maximum how many number of Boolean functions are possible? So answer to this question is to the power of n. So the justification to the answer is this. It is the best approach. Alternatively, we can speak, taking an example of 2 variables, we are having 4 combinations. So when we are developing a function, each combination we are having a possibility maybe as a minterm or maybe as a maxterm. When the function is a minterm, its value is 1. Sorry. When a product is a minterm or a combination is a minterm, that combination value is 1. When a combination is a maxterm, that combination value and the function must be 0. So 4 combinations we are having, each combination may be either 0 or 1 value when we are developing the functions. In terms of instead of talking in terms of the maximum, in terms of the logic 0 and 1, if I talk on these 4 combinations, we are having a possibility either maybe each one maybe with the logic 0 or logic 1, that is with the maximum or maybe minterm. So based on this 4 to the power of 2, the answer is 16. Like this also you can talk. So better convincing definitely you can make with this comparing to this, but as for your convenient, try to remember. And written exam is concerned, okay, all that work not matters. Remembering the formula, this is important. So let us try few questions of number system from the workbook chapter 1. So first question, let us look. The first question we are having, 235, the radix of R1 is equal to the decimal 565 is equal to 1065, the radix of R2. We are having some ABCD options. So which option is coming to be true for radix R1 and R2? That is the question we are having. So while looking to this, we must able to speak R1 must be greater than decimal 10 and R2 must be less than decimal 10. This conclusion we supposed to speak. If we take the question how it is so. Suppose we are having a decimal 120. This decimal 120, if we read as a hexadecimal number, if we read as a octal number, if you try well, the hexadecimal number will be 78. The hexadecimal number, if you try well, it is 78. And octal number, if you try well, it is 1320. Octal number will be 1320. So this decimal 120, when we are expressing with the radix of say R1 is 16, it is 78. When we are expressing with the radix of R2, that is 8, it is 1320. So what we are looking, the decimal number is the 3 digits. When it is expressed with the hexadecimal R1 is greater value than 10. Hexadecimal base is greater than the 10. Then the number of digits are less. Okay. Or another way, the numerical value what we are having will be less. So this numerical value with the radix of R1 is less possible if and only the R1 value is greater than 10. Coming to this, here the number of digits are more. The number of digits are more if and only the R2 is less than 10. So like this, they are having a conclusion. Based on this conclusion, from the given options, if you look here, we are having possibility to discard option A and option C. We are discarding option A and option C. The reason is, in the option A, we are having the R1 value is 8, but R1, what is expected, must be greater than 10. Based on this, same thing what we are looking here. So option A and option C are not possible. And of course, with this, we are having a conclusion, R1 must be greater than R2. R1 must be greater than R2. For the remaining two options, of course, we are having R1 is greater than R2. Now, from the remaining, after eliminating out of 4 two options, while eliminating the leftover are 2 options, while substituting the values of R1 and R2, option C and option D, you can check which is coming to be true. So definitely, if you try, the answer for this question will be option B. If you try well, hopefully it is not a big deal. You can read the answer as option B. So answer to this question is option B. Coming to the question number 4, we are having the same number which is represented in the hexadecimal format, in the octal format. The question what we are looking is, what are the values x and y? X and y are related with the octal number representation. So when this is a question, the given number, hexadecimal number, is to be read first in the binary format. When we are reading as a binary format, we already discussed, each digit is to be expressed with the 4 bits. So while expressing each digit with the 4 bit, we are having, it is the binary format. It is the binary format. So 9, this is C is nothing but 12, 2, it is 1. Now to read its equivalent octal number, we are doing the grouping of the 3 bits. While going with the group of 3 bits, we are looking, it is one group, second group, this is third group, it is the fourth group, it is fifth group. So from this group we are having here, this group is 1, this group is 1, this group is 3, this group is 1, this group is 1. So we are having here, this is 1, it is 1, next it is 1. So based on this, what we are looking, x and y. X supposed to be this 3 and y supposed to be this 1. So which is a matching answer from the given options? We check. The matching answer from the given options will be option A. So answer to this question is option A. So So let us come to the question number 6. The question number 6 we are having as some expression with the numericals. Now the question what we are having is, how many ones are present in the binary representation of this number? When this number is represented in the binary format, how many number of bits we are reading as a 1 in the binary representation is the question. While looking to this, we supposed to get an idea. The number what we are having here, basically we supposed to get an idea as it is a hexadecimal number. We must get an idea. It is an hexadecimal number 4975 with the base of 16. How we are speaking this? While looking to this, we can understand. This is 16 to the power of 0. This will be 16 to the power of 2. Based on this, it must be 16 to the power of 0. Coming to this, it must be 16 to the power of 3. Hence, this will be D3, this will be D2, this will be D1, this will be D0. The polynomial equation and the general notation what I given while discussing the number system, if you correlate, it is D3, D2, D1, D0 with the base of 16. So once we are reading this with the base of 16, to read the answer, no need to spend much time. For this, we are reading the equivalent binary format. So each hexadecimal digit is to be expressed by using 4 bits. So this will be 0, 1, 0, 0, 1, 0, 0, 1 for 9, next 0, 1, 1, 1 for 7, next 0, 1, 0, 1 for 5. It is a binary equivalent. And number of ones, that is the question. If you count the number of ones, we are having 3 plus 2, 5 plus 2, 7 plus 1, 8. So from the given options, the answer to this question is option A. So answer is option A. So come to the next question, that is question number 10. Question number 10 in the new workbook is minus 539 with the base of 10 in hexadecimal is when this number is expressed, this hexadecimal number is expressed in 2's complement form. The 2's complement representation of the decimal minus 539, that is the question. The 2's complement representation for minus 539 in hexadecimal format, it is a question. So when you want to express this number, the 2's complement form, of course in the hexadecimal format, let's look first. Plus 539, what is the hexadecimal equivalent? For plus 539, the hexadecimal equivalent will be having as plus 21b. If you try well, it is the hexadecimal equivalent. We want the 2's complement form in the hexadecimal format. So for this hexadecimal format, the binary format is 0, 0, 1, 0, 0, 0, 0, 1. B will be 11, so that 1, 0, 1, 1. So for plus 2, 1b, we are having our plus 539, it is a decimal value. The binary equivalent is this. Of course, it is nothing but hexadecimal of plus 2, 1b. Now for this, let us take the 2's complement operation. When we are taking the 2's complement operation for this, it will be 1, 0, 1, 0, 0, 1, 1, 1, 1, 0, 1, 1. Now this is to be read in the hexadecimal format. Hence we need to look here the hexadecimal equivalent for group of 4 bits. This is 5. This will be E and this will be D. This will be D. So from the given options we check, the matching answer for this will be option C. The answer to this question is option C. So quickly I will repeat once again this, don't get confused. Listen well and look to the statement what we are having in the workbook. We are having a question as here, minus 539 decimal number. It is a given number. The 2's complement representation of minus 539 in hexadecimal format. For this number, we want the 2's complement, that is to be in the hexadecimal format. Whenever we are having a given number as a negative and we want the 2's complement format, maybe hexadecimal, maybe octal, that is a different issue. We want the 2's complement, then better start for this number as a positive number. For this positive number, try to read the binary value. So to read the binary value, as I said, whenever the number, some time back while discussing the number system, I said, whenever the number is a larger value, better read first for this number equivalent hexadecimal. It will take the less mathematical work. That is the only reason why I considered this sort of thing. So for this decimal number, looking to this higher value, instead of going direct binary conversion, if you do the binary conversion, of course, it is the one what you will be having. My suggestion is better do the conversion to the hexadecimal form. If you do for conversion for the hexadecimal form, you are having only 2 divisions. But if you go for binary equivalent directly, we are having total number of divisions will be 9. Total number of divisions will be 9. So mathematical work will be less if you read directly as hexadecimal. So this I am looking as a positive number equivalent hexadecimal from this binary. For this binary, we are taking the 2's complement operation. After reading the 2's complement operation, the final answer you want to have for this 2's complement representation, the hexadecimal format. For this hexadecimal format, of course, if you try, these are the equivalent hexadecimal digits. From this, we are having answer is option C, D, E, 5. Come to the question number 18. Question number 18 is a good question. I will read the question as it is first. The question is talking, there is a 4-bit number x3, x2, x1, x0. It is in the 2's complement form. Particularly whenever you are dealing with the number system, in the question, whenever we come across the wording 2's complement or 1's complement, my suggestion is better put underline when you are working yourself. If the question is coming, description, the number is the 1's complement or the number is the 2's complement, better my suggestion is put underline. Whether it's the 1's complement or the 2's complement, with the prefix word sign is in mentioned or not mentioned the problem statement, default it is an indication signed 1's complement and signed 2's complement. It is a default indication. We are having here a question as a number 4-bit 2's complement representation is x3, x2, x1, x0. The number when stored using 8-bit will be, the number stored with the 8-bit will be, it is a question. From the given options, if you check, we must speak answer to this question is option C. It is as good as with your CO knowledge you can speak. It is as similar to the sign extension. Of course, you can speak directly. It is a sign extension question only. The sign extension. So, answer we supposed to speak with any sort of work as option C. So, let us work with a little more details. When this number is in the 2's complement form, we are having a possibility the number may be positive or the number may be negative. Suppose the number is positive, consider it is a plus 5. If the number is plus 5, its representation in the 2's complement form 0, 1, 0, 1. Don't get confused. I said already, when we are having the numbers are positive numbers, when the numbers are positive numbers, the true magnitude, sign true magnitude, sign 1's complement, sign 2's complement is one and same. So that whenever the number are positive, no need to perform any complement operation on the positive numbers. The complement operations we need to perform whenever the numbers are negative numbers. Once it is a positive number, it is as it is. When this number we are expressing with the 8-bit format, when we are expressing this number with the 8-bit format, let me consider the bits as B7, B6, B5, B4, B3, B2, B1 and B0. This plus 5 will be expressed as 0.0000101. It is expressed as like this, plus 5. Similarly, let us take the number as -5. And the -5, if it is expressed in the 2's complement form, it must be 1101. The 2's complement representation for -5 will be from LSB to MSB if I speak 1101, or from MSB to LSB if I speak 1011. When this -5 is represented with the 8-bit format, we are having it is 1 1 0 1 1 1 1 1. Okay. So it is -5 represented in the 8-bit format. So the question what we are having, a 4-bit number which is in the 2's complement form, which is copied into 8-bit register. So the number which is already available in the 4-bit format, it is copied into 8-bit. So it is as good as something like this. We are having a 4-bit CPU. The 4-bit CPU data is copied into 8-bit CPU. When 4-bit CPU data is copied into 8-bit CPU, how this number is copied is a question. So it is upgradation. It is as good as upgradation. So once we are having possibility of arithmetic operation of 4-bit of this number in the 4-bit processor, definitely this arithmetic operation is possible even in the 8-bit CPU. So it is as good as upgradation. So in a simple way is mentioned in the question as a 4-bit data what we are having as x3 to x0, when it is copied to 8-bit, what is its representation of the 8-bit is a question. Because the 2's complement, we are having a possibility the number may be positive, number may be negative. So with the number positive or with the number negative, what is the representation for some sample number we considered with a 4-bit and 8-bit, and from this work we are trying to look to the answer. In fact, I already mentioned answer, but elaborately we are looking here with the detailed work. So what we are looking is here, these 4 bits x3, x2, x1, x0 are copied as it is in the least 4 significance of 8-bit number. In the least significant 4 bits, are copied these 4 bits as is, whether it's a +5 or -5, we are having as it is, they are copied. You can look for negative 1011, for positive 0101. It is copied as it is. And the most significant remaining bits of this 8-bit, the most significant bits are B4 to B7. So in these most significant bits, we are having the x3 bit which is copied here. If x3 is 0, 0 is present here. If x3 is 1, this 1 is present in the remaining 4 bits. So least significant bits of this 8-bit register is having the data as it is of this 4-bit number. The least significant 4 bits are from this B3 to B0. They are having a data as it is of the original 4-bit number. And the most significant bits of this 8-bit register are having the data, are having the bit, which is MSB bit, of 4-bit. MSB bit for positive number is 0, so remaining bits are zeros. MSB bit for negative number is 1, so the remaining bits are 1. So based on this, we are looking from the options. The matching answer is option, I think I mentioned as C. Look from the options. Yes, it is option C. The matching answer is option C. As I said, without doing anything, it is as good as work of sign extension. With the knowledge of the CO subject, we can talk it is a sign extension. In the 2's complement numbers, the sign bit is x3 bit for 4-bit. So when it is copied into larger size, this sign is to be copied in the remaining bits. So simple way you have to remember like this. So it is copied in the remaining bits, the MSB bit. So let us come to the next question. Question number 26. All these questions are from chapter 1. So we are having here a question, minus 64 plus 80 with the radix of 16, whereas minus 64 is the radix of 10. It is equal to, it is the question what we are having. So look well in our workbook. This is question number 26. What is its equivalent decimal value is the question. For this number, we are having the base is 16. For this number, we are having a base is 10. When we want to add these two numbers, we need to have both the numbers the same radix. Same thing even for subtraction. Whether it is addition or subtraction, or in general for any arithmetic operations, all the numbers must be with the same radix, with the same base. So the number which is not with 6, not with 10, not a decimal number, better it is we need to convert into decimal number. If you convert this into the decimal number, it will be 128. Sorry, 128. Now it's a decimal number. It is a decimal number. So we are looking, the result is plus 64. Hence, answer to this question is plus 64. Coming to this, the given number, it is mentioned in the problem statement as it is a 2's complement. What is its equivalent decimal value is the question. Look to the statement. The question what we are having is, a number is expressed in binary 2's complement as 10011. Its decimal equivalent value is the question. So when we are having what is its equivalent decimal value, the number what we are having, it is negative number. The number what we are looking is here negative number, because MSB bit is 1. Once it is a 2's complement, whether a prefix word sign is used or not, repeatedly I am mentioning, default is sign 2's complement only. So while looking to this is negative number, so one of the procedure what I said is, first we are writing sign, later to read the magnitude we are performing 2's complement operation on the total content of the register. While performing the 2's complement operation on the total content of the register is the number. From this we are reading its numerical value is 13. Along the sign bit, it's a minus 13. It is one way I said, one approach I given. Alternatively, what I said is minus 2 to the power of number of bits right side of this MSB. The number of bits right side of this MSB we are having in this example as 4 into 1. MSB bit is 1 plus, I said, the decimal equivalent value of this. The decimal equivalent value of this is 3, because 0011 is 3. From this we are having here, it is minus 16 plus 3. So answer is minus 13. Of course, either way, the answer is supposed to be same on the same number we are having, as this is one approach, that is another approach. So anyway, answer to this question is minus 13. Come to the next question. The next question is question number 30. In the question number 30, we are having a equation, and we are having the number system. It is mentioned as x, that is the base is x, that is the radix is x. The question is, what is the x value? When we are having what is the x value, we need to evaluate this. This will be now x square into 1 plus x into 3 plus x to the power of 0 into 5. So x to the power of 0 is 1, so 5. So as I said, general notation, that only I am using d2, d1, d0. So x to the power of 2 into 1. x to the power of 1 into 3, x to the power of 0 into 5. So it is the one what we are having. So similar work are extending for other two numbers. So x square plus, I can write 4x directly, but anyway for clarity I am putting here x into 4 plus 4. Right side we are having x square into 3 x into 2 plus 3. So we are looking here. So 2x square, if any numerical mistake is happening, make a check yourself later if required. So at 2x square, 3x plus 4x, 7x, 5 plus 4, 5 plus 4, 9. So 2x square, 7x, 5 plus 4, 9 is equal to 3x square plus 2x plus 3. So this is effectively x square minus 5x minus 6 is equal to 0. So roots, if you look here, I think one is 5, one is minus 1, I think so. Let me check. So I can look here, x square minus 6x plus x minus 6 is equal to 0. If you take x is a common, x minus 6 plus x minus 6 is equal to 0. So this will be effectively x minus 6 into x plus 1 is equal to 0. So possibility x may be 6 or x may be minus 1. But we can't build number system with the negative numbers. Because of this is not at all possible. Possibility is only this. Hence answer to this question is 6. Answer to this question is 6. Come to the next question. Next question is question number 31. Question number is 31. We are having here a question as 312 divided by 20 is equal to 13.1. It is with some number system which is having a radix of r. It is a question. We are having in some number system that is the radix of r. It is the equation we are having. The question is, what is the radix r is a question. The question is, what is the radix r value? So it is similar to the previous question number 30. But maybe looking to be little, the first instant looking to be little complex way. But of course, overall work is coming similar to the question number 30. So each number we are having with radix of r. Hence we are looking here 3r square plus r plus 2 divided by 2r plus 0 is equal to r square into 1, no need to write, plus 3 plus r to the power of minus 1 into 1. Directly I am writing. So if you look once again, the numerator is 3r square plus r plus 2. Denominator is 2r plus 0. Right side it is r square plus 3 plus r to the power of minus 1. The polynomial equation what we discussed while discussing the number system that we are using here. So here further work, mathematical work, 3r square plus r plus 2, right side while taking the cross multiplication, this will be now, sorry, this is r only, not r square, sorry. So r only this is. So right side, if you look here, this will be 2r square plus 6r. 2r square plus 6r plus 2 plus 2. So we are looking here. This 2 LHS RHS we can remove, we can cut. So the leftover terms r square minus 5r. So r square minus 5r, r if you take as a common, r minus 5. So once r minus 5, the roots possible only are equal to 5. Hence, answer to this question is 5. Answer to this question is 5. So let us continue. Chapter 1, question number 32. The question number 32 is 2's complement representation of 16-bit number. 2's complement representation of 16-bit number is 4f's. The question is its magnitude in decimal representation. Its magnitude in decimal representation. Once the 2's complement form, default design 2's complement only. Whether it is mentioned or not, it's not the issue. It is to be. But anyway, in the question it is given 1 sign bit and 15 magnitude bits it is mentioned. If at all such information is not available also in the question description, default meaning MSB is a sign bit, the remaining bits will be related with the magnitude. In fact, it is a question 93 gate question paper. So if you look here, its magnitude is talking in decimal form. F will be, all 4 bits will be 1. The number is in the 2's complement form. Once the MSB bit is 1, number is a negative. So magnitude is not true magnitude. The magnitude is in 2's complement form. To read the decimal equivalent value for the magnitude, we need to perform the 2's complement operation on this. While performing the 2's complement operation on this, it will be 1, remaining all will be 0. So number is -1, but based on the question, our interest is only on the magnitude. So answer to the magnitude is this one. It is a magnitude. So answer to this question is not -1. Answer to this question must be 1. Come to the next question, question number 33. The question number 33 is the minimum decimal equivalent value of the number 11C0. The minimum decimal equivalent value for this number. So here we are having the usage of the symbol C. With the knowledge of the hexadecimal numbers, I said whenever the radix value, that is the base value, is greater than 10, from 10 onwards we are using some symbols. 10 onwards we are using some symbol. It is the same situation, but here we are having in the question description one word, minimum decimal equivalent value. This is the important word here. So once we are looking a word minimum decimal equivalent value, better put underline for that word. That key attention to you to give the correct answer. So minimum decimal equivalent value for this number, we are having the usage of the symbol C. Conventionally you have to think, so definitely 3 symbols must be used after this 9. After this 9, these 3 symbols might be used for reading C. They are supposed to be used. So minimum we are looking based on this. This is 10, this is 11, this is 12. Hence the radix, if it is 13, then only they are having possibility for usage of the symbol C. If we are not having the wording as a minimum, then the radix is possible on this number, any decimal value greater than 12. If this word is not there in the question description, we are having a possibility for the radix greater than 12. But minimum is possible not by using 14, 15. Minimum is possible if the radix is 13. Hence, we are decided based on the wording, its base is 13. Once we are deciding its base is 13, the remaining part is easy. And if you check well, the answer to this question is 194. So 13 base. So general description D0, D1, D2. With this notation, we try well. Answer is 194. Come to the next question, question number 35. This number is the base of B is equal to decimal 5. The question is, what is the radix B value? I was talking while discussing some other question. Whenever we are having some arithmetic operations, the arithmetic operations are possible whenever both the numbers are with the same radix. RHS number is with the decimal value, that is the radix is 10. Hence, before proceeding further, better to convert LHS number also as equivalent decimal number. If you convert as equivalent decimal number, this will be 4B plus 1. Then this is the decimal. Then this is the decimal value. While having decimal value, LHS and RHS with the same base, let us take the square both sides of this equation. While taking the square for square both sides of this equation, we are having this. So from this we are looking 4B is 24. Hence B will be 6. So answer to this question is 6. Question number 35. The answer to this question is 6. Come to the next question. Next question I said, try yourself question T7. Of course, the answer is available, but we need to identify how this is the answer. It was the GATE question in 2014 GATE CS paper only. It was a question. It is the solution is available even in the GATE solution book of CS. But anyway, let us discuss here. 1, 2, 3 with the base of 5. Right side x8, base is y. We are having here a question. With x and y as unknown, the number of possible solutions to satisfy this equation, the number of possible solutions, it is a question. The question is not to find what is x value, what is y value. The question is how many possibilities we are having to satisfy this equation. It is a question. So we are looking based on this few conclusions. Conclusions what we are having is y must be greater than x. Y must be greater than x, then only you can represent as x8. So radix must be greater than any digit in any number system. And also y must be greater than 8. And also y must be greater than 8. So these conclusions we need to remember while answering to this. If these conclusions we are not remembering, there is a possibility to speak the wrong answer. Now, the equivalent decimal value for this is 38. And if you evaluate this, it is xy plus 8. Hence, xy is 30. xy is 30. Once xy is 30, now if you list x and y values, which are the possibilities? So, the possibilities what we are looking is y must be greater than 8. One possibility, y is 30, x is 1. So y is greater than x, y is greater than 8. Next possibility, y is 15, x is 2. Y is 15, x is 2. So y is greater than 8 and y is greater than x. Next possibility, y is 10, x is 3. So condition satisfy even here also. And suppose you are looking, as, say, x is 10, y is 3. Just think whether it is possible or not. And similarly, x is 30, y is 1, possible or not. If you think, they are not coming to be true. Because y must be greater than 8. Y must be greater than x. So those conditions are not satisfied. Hence, we are looking, these are not possibilities. We think like this, we are having such 3 possibilities. So basically, we are looking to the roots. So this is 215 ja, 53 ja. From this work, I mentioned these things. Hopefully, you know. Anyway, while using these conditions, if we look here, these are the 3 possibilities. So answer to this question is 3. It is printed in the workbook because of the try yourself question. The answer is 3. Come to the next question. The next question is T8. So T8 we are having as a number 73 with the base of x is equal to a number 54 with the base of y. This is possible while working one question I already mentioned. Y must be greater than x. Y must be greater than x. So y is greater than x means what we are looking, this y must be greater than 7 default. Y must be greater than 7. The reason is, based on this, x is greater than 7. Once x is greater than 7, y also must be greater than 7 because y must be greater than x. Why? How we are speaking? The numerical value what we are looking, it is smaller than this. That is possible while working one question I already mentioned. It is possible if and only the radix y is greater value than x, the numerical value we are reading as smaller. So these conclusions, while knowing from the given options, you have to choose the answer. So while looking to these conclusions, if you try the answer, y must be greater than x. Anyway, if you try well, answer is option D. Come to the next question. T14. T14, we are having a system S. The system S is consisting of a block of 1's complement and a block of 2's complement. The block of 1's complement is having a input number I, which is with 4 bits, I3, I2, I1, I0. And we are having output y, each 4 bits. So y is y3, y2, y1, y0. Y0. So This is named in the question description as system S, and there is a system H which is built by using three such S systems. Three such S systems are used. Three such S systems are used. So, while cascading three such S systems, the system what we are having that is named as H system. Question is, when a number 1010 is fed as the input, then what is the output is the question. To speak the answer on this question, we need to know first what is the operation or what manipulation a system is doing on the given number, on the given input. We need to understand the functionality of a system. Once we are understanding the functionality of the S system, we can speak now with this cascade connection what is the answer we are having for the given question. The functionality of the S system possible to understand the known knowledge of the ones complement and twos complement. So if you look here, first we are having ones complement operation on the given number by using the first block. Later we are having twos complement operation. Twos complement operation is nothing but ones complement plus 1. Here we are having ones complement, here one more time. So all together in this block we are having on the given number the ones complement operation we are looking on 2 times. So given number some A 2 times we are having means it is resulting same A, and of course this is plus 1. Hence effectively its operation is output is nothing but input plus 1. The output y we are having as input plus 1. The operation of the S system is just adding 1 to the given input number. Coming to this H system, we are having 3 such S blocks. So each S block is adding 1. Each S block is adding 1. The given number is 1010. So for this 1010 we are adding these 3. Is it? It is as good as 10 plus 3 binary form I am using. So based on this, if you look here, it is 1, it is 0, it is 1, it is 1. So answer is 1101. It is a good question. With a little attention, if you work out without any difficulty, you can speak the answer. The printed answer anyway, it is there, the workbook as this. Let us come to the next question. It is a good question. It is a question from the previous GATE paper. In 2006 GATE exam, it was a question for 2 marks. We are having here one number with bits A3, A2, A1, A0. It's a number. Read the question. Read the question from the workbook. The question is mentioned. This number is in the 2's complement form. This number is in the 2's complement form. And of course, it is mentioned it is equal to integer n. When this number is copied into 6-bit register, after few mathematical manipulation, the final result we are having is mentioned as A3, A3, A2, A1, A0 and 1. So final result we are having as this. Now the question is, the value of this bit pattern, of course, in 2's complement form is given in terms of the original number n. It is given in the original number n is a question. I will write as subscript. So quickly I will repeat the question. A number n, integer number stored in a 4-bit 2's complement representation as A3, A2, A1, A0. It is copied into 6-bit register, and after few operations, the final bit pattern is A3, A3, A2, A1, A0, 1. The value of this bit pattern in 2's complement representation is given in terms of the original number. It is a question. If you look to the notes, or if you rewind the video and if you see, I given a equation. When I am having a number with n bits, bn-1, bn-2, and so on, b1, b0. When this number is in the 2's complement form, its equivalent decimal value we said with this equation to the power of minus to the power of n-1, bn-1 plus to the power of n-2, bn-2, and so on to the power of 1, b1 to the power of 0. This is the equation you can see in your notes. When this number is in the 2's complement form, to evaluate the equivalent decimal value, we are using this equation minus to the power of n-1 into MSB bit, that is bn-1. For the remaining bits, it is only plus. So by using this, while evaluating, we are having its equivalent decimal value. So this knowledge we can use, this equation we can use here. So once it is in the 2's complement form, this will be now minus 2 to the power of 3 A3 plus 2 to the power of 2 A2 plus 2 to the power of 1 A1 plus A0. So this is equal to the integer n. Of course, it is a decimal form, default means it is a decimal n. Coming to this, when it is copied into this original number, when it is copied into 6-bit register, after few operations, after few arithmetic operations, if you look here, this must be minus 2 to the power of right side of this MSB. How many bits we are having? 1, 2, 3, 4, 5. So minus 2 to the power of 5 A3 plus 2 to the power of 4 A3 plus 2 to the power of 3 A2 plus 2 to the power of 2 A1 plus 2 to the power of 1 A0 plus 1. So let us name, it is a decimal k. So this is minus 32 A3 plus 16 A3 plus 8 A2 plus 4 A1 plus 2 A0 plus 1 is equal to decimal k. Same way, if you read here, this will be minus 8 A3 plus 4 A2 2 A1 plus A0 is equal to n. Let me name this as the equation 1. And we are having further manipulation here possibility. Minus 16 A3 plus 8 A2 plus 4 A1 2 A0 plus 1 is equal to k. So in this equation 2, let us take 2 as common. If you take 2 as common, what we are having here, minus 8a3 plus 4a2, 4a2 4a2, 2a1 plus a0 plus 1 is equal to k. So from the equation 1, we are having possibility to substitute minus 8a3, 4a2, 2a plus 2a1 plus a0 as equal to n. So this total thing we are substituting using equation 1 as n. So 2n plus 1 is equal to k. So based on this, after copying this 4-bit number into 6-bit register with few mathematical manipulation, if at all this is the final result, the relation with the original number n is 2n plus 1. Hence answer to this question is 2n plus 1. From the given options, I think the answer is option D. Let me check. The answer from the given options, it is option D. Yes, it is option D. Of course, it is printed, it is available, it is a printed answer. So we discussed few of the questions from the chapter 1 numericals based on basically number system, all numerical questions more or less. So we discussed some questions from the chapter 1, and also we discussed few of the questions in the chapter 2, because what the theory we covered till now, they are related with the chapter 1 and chapter 2. And what the questions are not touched, you try yourself in the meantime. After some time, I will discuss few other important questions, few typical questions. In fact, from the workbook, if you look, few of the questions on your own, you can try. Few are the routine questions or similar questions we are already covering in the theory part, so such things you can try. Few of the questions little typical, such questions definitely I will be giving solution in these video sessions. And where we are looking little simple, maybe giving answers. If still any problem, the feedback channels you can ask, we'll try to give the answers.